Well, this is the second part of our lesson on solving the volume of composite figures. In the first lesson, we saw this figure could be divided in two different ways. And again, remember the mathematicians use the fancy word decompose. What they're really meaning is they're just cutting it apart. Okay, so one way is to cut it going up and down this way, the other way is to cut it this way. And we solved it both ways, and we found that regardless of whichever way you did it, the volume was the same. The volume was 315. Okay, so now I'm going to narrow this down, and we're going to do one problem together. I would like for you to get your calculator and your pencil, and either if you're going to join me on page 371, you can join me on page 371 in your textbook, or just a piece of scratch paper. So go ahead, get a pencil, paper or textbook, and calculator. All right, now that you have what you need, we're going to find the volume of this figure. And it doesn't have any particular name. To me, it looks like an upside down T, but hopefully you can see how you could cut that apart into either 2 boxes or possibly 3 boxes. Probably the easiest way to do it would be to draw a line right here and cut that top box off. Now, you might have seen another way. You might have thought maybe, well, you could cut it here, and then maybe you'd have 3 boxes or 4 boxes, depending on how you look at it. Okay, cutting into 2 boxes will be a little bit easier because then you only have to find the volume of 2 things. So I would like for you to make 2 lines. I'm going to draw another line here, and we're going to figure out how to figure out the volume. So I'm going to do the top box first, and you remember that volume is equal to length times width times height. Or you could say height times width times length, or width times height times length. When you're multiplying, it doesn't matter what order you do those in. So I'm going to look at the top box, and I see this measurement here is 4. So I'm going to do volume 1 for box 1, and then I'm going to do volume 2 for box 2. You don't have to label them just like that. You could say box A and box B. So the first one, I've got a 4, and then I have the height is 2. Okay, so I've got this length and I've got this length. I'm missing this side right here. So remember that the opposite sides of a rectangle are equal. So this side is equal to this side, which is equal to this side, which is equal to this side, which is 5. And I apologize, my cat is meowing in the background here. So we could multiply those 3 together and we would get the volume of that top box. Those numbers are easy enough, you can do it in your head. And it would be, do the 5 times 2 to get 10. Times 4 is going to be 40, and our unit is feet, and it's going to be cubed. And I'm writing on my Surface board, which is kind of wobbly, so my handwriting's not going to be the neatest, but I think you can read those numbers okay. All right, so we've got the top box taken care of. Now we have to find the volume of the bottom box. Again, volume is length times width times height. And I can easily see that right in the front here, I've got a 14. It's going to be my longest side. I'm going to call that the length. The width over here is 5. And the height is 3. Okay. This one, unless you're really good and know your 14s and your 15s by heart, it's probably going to be a little bit tricky. So grab your calculator and multiply 14 times 5 times 3. And you should get 210 feet cubed. Now, the volume of the top box, 40. The volume of the bottom box, 210. Altogether, it's going to be 250 feet cubed. All right, let's take a look at a real-life problem with a composite volume figure. I'm on page 372 if you're following along in your textbook. Here we have a building. It's a warehouse, and the big box, or the big part of the building, is the warehouse, and then they also have a little smaller part that's an office. They want to know how much space it takes up. Now, by space, they mean like if you were going to fill it up with boxes of stuff, how much space would you have? All right, so just like before, we have to cut it apart into boxes. And so you can very easily see that you have a smaller box down here and a bigger box in the back, right? Okay, doesn't matter which box you figure out first. Sorry, I'm erasing this. But we're going to find the volume of the first one and the volume of the second one. Okay, so again, I wish they would have given us 2 lines here, but we're going to figure out the volume of both of them, and from there, we're going to add them up together. Okay, all right, so let's do the big box first this time. So I can see the height right here is 12. That's easy. The length is 50. And then it's 30 feet or 30 meters wide. So those are my first 3 numbers. Remember, volume is length times width times height. Second one, another easy one. I don't have to do any figuring here. I can just see it's 15 this way. It's 5 meters, not 5 feet, 5 meters. 5 feet, you'd have to duck to walk in there. And then 10 meters wide. All right, so now I'll take your calculator and figure out the volume of the first one. You're going to multiply those 3 numbers together. It doesn't really matter what order you do them in. And you should get 18,000. And the second one, you should get 750, and again, those are meters cubed because you had meter times meter times meter. Add them all up, this you can do in your head, 18,750 meters cubed. 3D, it's cubed. All right. Now, we're not going to go through every problem in your textbook, but I do want to talk about the next problem. So I'm going to scroll this down to this problem right here. And in this situation, they're wondering about putting a new furnace in for this building. Okay, maybe it's an apartment building, or I'm not sure, but they want to make sure that they have a big enough furnace to heat everything or air condition everything if you're someplace in a hot climate. And so they want to know how many cubic feet you have. Well, in this particular problem, what you would want to do is you'd want to divide it up. You could divide this portion of the building right here and divide this portion and this portion. So you would end up having 3 different volumes to figure out. Again, length times width times height for each one of them. And then add up the volume of this one and the volume of this one and the volume of this one, and you'd have the volume for the entire thing. All right, I think I would like to go through this last problem with you because there's going to be a problem similar to this on your homework. So here we have steps, concrete steps, and let me just read the problem to you. It says, an in-ground swimming pool often has steps that are made from poured concrete. In the sketch of the steps at the right, the steps are identical, each measuring 18 inches from side to side, 12 inches from front to back, and 8 inches tall. Calculate the amount of concrete that's needed to form the steps. Okay, I'm going to pause here for a minute. I want you just to kind of think about how you could do that. All right, Let's talk about the different ways you might have decided to decompose or cut this figure apart. Okay, one way, maybe you saw, this is not going to show up very well, maybe you saw some different rectangles like this. So you saw some boxes going across that way. That's one way of doing it. Okay, so you find the volume of this one, the volume of this one, and the volume of this one. Some of you thought, oh, I didn't see that at all. Maybe you thought of it as going like this way. There's a small box there, a longer one this way, and a super long one that way. That would be another way of doing it. Okay, here's another way. This is probably the easiest way of doing it. I thought of it like this. So here's your first step. And if you figured the length times the width times the height of that first step, this one right here is really 2 steps high, right? So you've got a step here, a step here, a step here, and then over here, it's really 3 steps high. So you've got step 4, step 5, step 6. And all those steps are the same length. So if you figured out the volume of one of them, all you'd have to do is multiply it by 6 because you've got 6. So I would do 6 times, and it's 18 by 8 by 12. Okay, let's just figure out what the 1 would be, the parentheses. 18 times 8 times 12 in your calculator. And you should get 1,728. So each one of those steps is going to be 1,728 cubic inches. You have 6 of them, so multiply it by 6, and you get 10,368 inches cubed. Okay? Again, no matter which way you cut it apart, as long as you're doing the length times the width times the height, and you multiply them together, and then you add the volume of the different boxes together, you're going to get the volume. Hopefully you understood that. Today's homework is going to be doing a Think Central lesson. I'll be available. You can message me. You can Zoom with me. If you need me to Zoom with you, I can share my screen with you, or you can share your screen with me, and we can work on them together. Good luck.